Hey, what's going on, everybody? Welcome to Under the Hood, Ask a Pro. My name is Tony. We're live every Thursday at 3 o'clock to answer your car questions. Today, we're not live. I'm actually recorded this a couple weeks ago. So if you're watching this now, I'm practicing for a fishing tournament on the water and hopefully doing a good job. So last week, we talked about air conditioning, and what I want to talk about today is more of the inside of the air conditioning system and how the HVAC system works. So to start with, we'll talk about how the air moves through the system, and that's the blower motor. So we have a motor where a power and ground is supplied and a fan is turned. And with that fan, it'll actually blow or move the air. And if you notice, we have different speeds on our fan. So what we do to control this fan speed is we have what we call a blower motor resistor. And what this does is when we supply battery voltage or a car's running, let's say 13, 14 volts, we have our high speed. So as we drop the voltage, the speed on the fan will actually go down and decrease the volume of air coming in through the vents. And that's where the blower motor resistor goes into. So a lot of times, if you have a system that's not working on speed 2 or 3 or only 1 speed, most likely this is probably the culprit. To test it, you have to make sure we have inputs and grounds. Sometimes you'll have a pulse width modulated motor, which is a little bit difficult to test on your own without a meter or a lab scope. But the motor itself hasn't really changed. You know, the power and ground supplies it. The more voltage, the faster the speed, the more volume. The less voltage, the slower the fan speed. So we have the air moving through the system. What we need to do is direct the flow to either face, floor, or vents, or through the evaporator core or through the heater core if we want heat or air conditioning. And what we used to use little vacuum actuators and divert the airflow. Now we use electronic actuators, and it's just a motor. And what that does is it moves this metal piece here, and a door will direct the flow. So it'll direct the flow if we want it on their face, if we want it defrost, or if we want it on the floor. Another actuator we'll have is for the temperature. We call it temperature blend door actuator. So if we want heat, it'll actually open and close the door to either pass it through the heater core or the evaporator core. These evaporator cores are pretty tricky to get to, especially these actuators. And we have a car over here we're working on where these actuators are. Most cars, you can replace them in a few hours. Some cars, you actually have to remove the entire dash. And by dash, I mean the dashboard. So on this particular car that we're working on now, this Toyota, we are doing, we're getting to the expansion valve, which I talked about last week. So to able to get to it, it is buried. We've actually have this one out. It connects in between the evaporator core here, and we have the AC line. So to be able to gain access to that, we actually had to remove that whole dash pad. If we were replacing the evaporator in this core, what we would have to do is to remove this bar and this white box. This is the heater box itself. On this particular car, we can see our blower motor. One of the actuators is right back in there. We have some of the duct work. That's our venting for the defrost. So a lot of times when we have an evaporator leaking in a car, it's a pretty expensive job, and the reason is there's so much labor involved to get to this point. And like I said, we're about halfway there. If we were doing the evaporator core, we probably still have a few more hours to remove that entire box out of the car. And it's one of the first items installed in the vehicle. So that job is pretty much a full day. Depending on the car, could take 2 days of a technician being on it, working on it continuously. The big failure rate, we see evaporators leak. That's fairly common, but what we see a high failure rate is the actuators itself. So I have one here. Now I'm going to take apart for you and just kind of show you what's in them. So let me set up the stand here. You're going to need 2 hands. I've taken this apart, and all it is we have a motor. And it has a power ground that goes to it, and it'll switch the polarity. And if it switches the polarity, it'll actually move these gears. So if we want the door to go this way, it'll put positive and negative. If we want to go the other direction, it'll switch it. Then all of a sudden the door will turn the other way. The other circuitry that's in here, we can take this apart, is we have position sensors in it. And the position sensor is actually over here on this one, the green gear. That way we know where the door is actually located. So when we turn the knob to hot, it wants to know exactly where that door is so it can shut off the power to these motors. What typically happens, and I've seen a lot on Fords, you'll turn your dial, nothing will happen, but you hear like a click, 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 click. Actually these gear teeth will actually strip and cause that noise, and also the door won't move. On this particular one, if we look right here, this resistor is actually melted, and it actually burn up the circuit board itself. So that's why we replaced it on this particular car. So even though we're not live, still feel free to post any questions. I'll get to them when I get back in town. If you have topics for next week, let us know. And until then, we'll see you next week. Bye.